Welcome to the lesson on the general probability rules. We're going to start off with a definition first. Union of any collection of events is the event that at least one of the collection occurs. Well, what does that mean? When we are talking about a union, A union B, event A happening, or event B happening, and we can write that like this: probability of A or B happening. And if we take a look at a visual representation of a union, down here is a notation. This means A union B. And we notice that the outer circles, A and B, event A and B, are outlined in blue. And so the letters A union B are also in blue. That actually shows you a visual of the probability of A or B happening is the probability that is enclosed by those two circles outlined in blue. Now we'll discuss the probability of multiple disjoint events. If events A, B, and C are disjoint in the sense that no two have any outcomes in common, then the probability of one or more of A, B, or C is going to equal the probability of A plus the probability of B plus the probability of C. Back before, when we had discussions on the intro to probability, we know that when we're finding the probability of one event or another event occurring, we can use the addition rule, and this will also extend to multiple disjoint events as long as they, of course, are disjoint. So let me visually represent what I just said. Okay, so we have events A, event B, and event C. And you notice they don't overlap. That means they're disjoint. They will not have outcomes in common. So we can extend the addition rule to this. So the probability of one or more go ahead and stylus isn't cooperating this minute. Let me erase that. Okay. The probability of one or more of either A, B, or C occurring is the probability of A plus the probability of B plus the probability of C. Now remember, this addition rule only works when these events are disjoint, meaning there is no overlapping and have possible outcomes that are in common. Okay, what about finding the probability of unions that are not disjoint? We will still use the addition rule to find out the probabilities of either A, B, or C occurring, but we'll have to account for where they overlap so that we're not actually finding the probabilities of partial areas more than once, what I like to call double dipping. So, okay, let's take a look at this. We have three events going on here. We've got the probability of A, B, or C. So we need to, let's go ahead and write that out in probability notation. So we want to find out the probability of either A happening, or B, or C. Okay, so we'll continue to use that addition rule. So we'll find the probability of A plus the probability of B plus the probability of C. Now we're going to have to subtract, though, where they overlap. So I'm going to have to go ahead and subtract the area of probability of A and B, B and C, here where they all three overlap, and then here where these two overlap. So that's going to look like this. So I'm going to have to subtract the probability of where A and B occur. And also subtract out where probability of A and C occur. And the probability of a B and a C occurring. and the probability of BC occurring. And that will give me the probability of either A or B or C. That's kind of a complicated look at not disjoint. But if we were only to have, let's say, two circles that overlap, we'll call this event A and B, and the intersection, which we'll say A intersects B right here in this spot, we would have to find either the probability of A or B occurring. In this case, it's a little bit easier. So we'll find the probability of A plus the probability of B minus the probability of A where A intersects B. So that's a much more simplistic, which is the two events overlapping in one spot. And thank you for joining me for the general probability rules.